Okay, move out. Ever see a television camera flying? Or watch a moving wheel that wasn't completely round? How many times have you seen a swimming tank? 40 tons of it. In case you haven't already guessed, it's all in the interest of science. Part of the Army Tank Automotive Center at Warren, Michigan. At this huge installation, military and civilian personnel are facing space-age problems of producing sophisticated machines of war. Sometimes the work of these dedicated men and women touches the area generally reserved for science fiction. A giant X-ray shows imperfections in cast steel. A sensitive sound recorder reveals valuable information of mechanical performance. Test and evaluate until each piece of equipment meets all specifications for ruggedness and dependability. Research for vehicles of every type and description. Vehicles to fight in mountains, jungles, and on beachheads. Products of the world's greatest arsenal. Development of weapons ready to carry America's power to any part of the globe. Here is the story of scientists, engineers, and technicians who are advancing the frontiers of automotive science and technology. In the heart of Detroit, the world's automotive capital, is ATAC, the Army Tank Automotive Center, and its Components Research and Development Laboratories. These are the top-flight scientists and engineers from the laboratories. It is their responsibility to ensure the mobility of the Army of today and increase the mobility of the Army of tomorrow. Theirs is a big job. They are responsible for the reliability of every component that goes to make up these modern machines of war. Upon their shoulders falls the responsibility to find and develop the components that will make our Army's vehicles the best in the world. They must create new concepts. New materials must be found. New problems must be solved. The solutions to these many problems involve research into a great variety of fields of study. In the materials laboratory, important research is being carried on in the field of microbiology. It is the job of the microbiologist to determine if components built for use in Army vehicles are subject to biological attack. To achieve this, microscopic strains of fungi are grown on the various materials that make up the components of the vehicle. Small growths, seen through the microscope here, feed on these materials. They grow at a fantastic rate, particularly in tropical environments. This could spell disaster in combat. The growth of these small organisms could immobilize a tank and cost the lives of many men. The search for effective ways of fighting these microscopic enemies is part of the challenge. Another enemy of vehicle components is ozone deterioration. Ozone molecules are always present in our atmosphere. Natural and synthetic rubber products that are in storage for long periods of time are particularly subject to this type of deterioration. To combat it, additives called anti-ozonate are blended into presently used rubber compounds. A component made from this new blend is then subjected to an ozone chamber. The upper half of this tire section was made of a new anti-ozonate compound. The other half was made of a standard compound. The half containing the anti-ozonate has not been affected. Our modern Army rolls on rubber. This unit is part of a tank track. Different compounds used in making tank tracks are submitted to the laboratory by private contractors. They are tested and checked to ensure that they meet the rigid specifications for use on Army vehicles. Hundreds of different rubber compounds have been developed and are on test today on vehicles of all types in every part of the world. Here in the Materials Laboratory, a new compound is being developed for possible future use. When the newly formed component comes out of the extruder, it is soft and pliable. It is then hardened in a vulcanizing oven to meet the final requirements of the job. These scientists and engineers face the critical task of continually increasing the mobility of Army vehicles and increasing the storage life of vehicle components. While the effectiveness of a modern Army is based on mobility and firepower, another important factor must be considered: the protection of men and vehicles. In the Materials Laboratory, various armor fabricating processes are tried and tested. Different types of welds are made on samples of armor plate. At the proving grounds in Aberdeen, Maryland, artillery projectiles are fired directly at the weld on each plate. The plates are then subjected to a thorough inspection and analysis, and firing reports are submitted to ATAC. One of the largest and most modern X-ray facilities in the world assures the Army that the heavy armor plate of its tank is free from internal structural defects. By means of a 15 million volt camera and protected by concrete walls 7 feet thick, men can see through 20 inches of solid steel. Highly skilled X-ray technicians, engineers, and scientists combine their skills and experience to make sure the American fighting man has the greatest possible protection. It was Army research and development that pioneered the 12-volt electrical system. The results of present research in 24-volt systems will be seen in the private and commercial vehicles of tomorrow. Here in the Instrument Electrical Laboratories, batteries submitted by contractors from all over the nation are tested and checked in the most thorough examination a battery can get. New materials are developed and tested to make the battery cases virtually shock-proof. A 6-foot drop onto hard concrete is only one of many practical tests they have to pass. After long exposure to low temperatures, to prove their capacity to function under the frigid conditions of the Arctic, batteries and components like this portable generator are tested for normal response. Other electrical components are given grueling tests in this laboratory. A generator is connected to a pre-programmed dynamometer. It operates for 1,000 consecutive hours at minimum and maximum speeds. It must maintain proper voltage outputs at all speeds throughout this period. High speeds and rough terrain add up to severe vibration problems for Army vehicles. This test on lamp filaments is far more intense than any condition in the field. The row of bulbs shows another test given a manufacturer's sample. A contractor must prove his product to be more durable than those of current suppliers. Through this competition, the general public also benefits because of the Army's insistence on better and better products. Testing is not the only function of the men of the Instrument Electrical Laboratory. The experimental wiring being considered here was designed to supply power and drive for the command cupola mounted on a tank turret. From this experimental concept, a working model was developed and is undergoing extensive testing. This machine subjects a tank track to the tremendous punishment it would receive as a component on the heaviest tactical vehicle. A different kind of testing of vehicle components and materials is done in the environmental laboratory. Here, a heavy command cupola is being tested on a circular raceway with a new alloy. It must operate under severe temperature ranges without chipping, cracking, or deforming. In this special laboratory, air filters are tested and specifications are set. Vehicle power plants, like people, must breathe. They must be able to breathe in the dustiest and most arid parts of the world. So dust and other impurities are induced into the filters to simulate extreme conditions. In this test chamber, men of science bring the Arctic to Detroit. Here, vehicles are cold-soaked for long periods of time at temperatures as low as 65 degrees below zero. The bitter winds that blow across the Arctic wastes are also recreated here. Lines for remote control and instrument recording are connected to the test points of vehicle components. From the room outside, the engine and other components will be operated and controlled. To prove the efficiency of the items under test, recording instruments are watched and checked and logged. Engine tests are performed at all gear ranges. Research in the laboratory permits the Army to fight in gale-force sub-zero winds on the Arctic tundra or in the hottest, driest, most remote corners of the Earth. Within the broad research and engineering activities of the Propulsion Systems Laboratory comes the testing and evaluating of engines and transmissions, as well as full-size vehicles under simulated loads at temperatures up to 160 degrees Fahrenheit. The lake outside is a reservoir of water needed to cool the equipment used in these operations. One of the largest wind machines in the world forces air through these hot radiators, simulating winds hotter than those of any desert region. Here, a tank is being prepared for full load cooling tests under simulated environmental conditions. Remote control and instrument controlling lines have been connected to the various package components of the tank. Continuous readings at each test point are made throughout the operation. The tank's track has been disconnected from the vehicle, and the sprocket wheel is hooked to the absorption dynamometer. Heat lamps are rigged above the tank to simulate the hot equatorial sun on vehicles. Wind speed and temperature control are maintained from the complex control room high above the floor of the test chamber. tank engine is started and operated from the control room. Instruments connected to the vehicle are constantly checked and logged by the engineer in charge. Often conducted in this facility are tests on Navy and Air Force vehicles, as well as vehicles from Allied countries. The resulting findings help establish international standards. The 8 other test cells in this laboratory each have their own control room and dynamometer. Each can simulate any desired wind forces and air temperatures. Men and women of ATAC's research and development work closely with research experts from engine manufacturers. Together, they develop new designs, new concepts to assure our armed forces maximum power plant reliability. One result of this cooperation has been the revolutionary power plant that operates successfully with a number of different fuels. This multi-fuel engine will prove to be a great asset to mobility in frontline operations when specific fuels are not available. The results of this kind of study of new automotive principles will soon be seen in civilian vehicles. Modern combat vehicles must be able to carry the fight to the enemy on any type of terrain. Mobility for the new Army must be maintained and continuously improved to meet situations that just a few years ago seemed next to impossible. The defense perimeter of the free world has expanded to include every type of challenge on the face of the globe. To keep up with this expansion, the personnel of the components laboratories are always trying to foresee the future needs of an Army on the move. At the Land Locomotion Laboratory, the ancient game of tug-of-war is used to demonstrate a new concept of the wheel. Here, 2 identical descendants of the Army mule, one with conventional wheels and one with a hubless wheel conceived at ATAC, are compared for traction quality. The hubless wheel, still in the infant stage of development, has attracted the attention of other scientific groups seeking new means of travel on the surface of the moon and other space objectives. Before new methods of locomotion can be devised, our scientists must learn about the ingredients that make up the terrain. Soil samples representing the most remote and rugged parts of the world are studied and tested. Working models of new locomotion concepts are put through strenuous tests in a soil test bin that is the closest thing to natural terrain that modern science can devise. Slippage, sinkage, and other factors are checked and recorded. A version of this particular locomotion system may someday move Army vehicles across swamps or through the wet and muddy jungles of the tropics. The hot, dry sands of the desert are simulated in another test bin. Different elevations and angled slopes are artificially created. The locomotion concepts of ATAC research experts conducted in this laboratory are supplemented by ideas submitted from other sources. Civilian inventors often submit models of their concepts for possible use by the Army. Detailed photographic and written reports are then evaluated to determine whether the new idea can contribute to the mobility of the Army of tomorrow. A factor that sometimes limits the scope of overall mobility is that our planet is crisscrossed with thousands of waterways. This laboratory test tank can simulate natural water obstacles of all types. In this man-made river, currents can be made to flow in any direction and at many forces. The resulting flow patterns and eddies are documented by the cameramen following the model. Here is another scale model under the watchful and critical eyes of the team of scientists, engineer, technicians. Each contributes to the cooperative effort that will make the resulting full-size vehicle better and more effective than the one in current use. Engineers from the Firepower Laboratory are engaged in a long-range program to help solve the problem of seeing what happens on the other side of the mountain. Using a space-age version of the observation balloon, the ATAC investigators have been researching a radically new device that can carry a miniature television camera to a height of several hundred feet to see over natural and man-made obstructions. As in this artist's conception, the aerial observation platform may be mounted in an armored reconnaissance vehicle. When ground-level observation is obstructed, the vehicle crew launches the device. Trailing its power and coaxial cables, it lifts the TV camera into the most advantageous position to observe the hostile terrain ahead. As the camera transmits the image to the observer in the vehicle below, he tilts, pans, and zooms to scrutinize the entire area. In addition to providing close surveillance from a protected position, the device may prove of value in fire control, radar detection, missile guidance, and a variety of special uses. Suspension systems that permit better riding characteristics and a more stable gun platform is one of the jobs of ATAC's research experts in the Track and Suspension Laboratory. One outstanding result of this research is the hydro-pneumatic springing device, which allows tracked combat vehicles to negotiate broken terrain at higher speeds and to provide a self-leveling firing platform for vehicle armament. Test capabilities of the Track and Suspension Labs are not limited to the main facility at Warren, Michigan. Through the use of its mobile laboratory, new vehicles such as this model submitted by a civilian contractor may be tested anywhere in the country. Results of these tests can be evaluated immediately by the technical personnel who man the mobile laboratory. Perhaps the greatest challenge for the men of the components laboratories is to meet the complex demands of the sophisticated vehicles still on the drawing board or mock-up stage. They must design and build new and more efficient vehicle components. Components that must stand up under more severe conditions. Components made of new materials. Components designed for installation in odd-shaped cramped areas. To get this gigantic task done calls for the most advanced technologies of the scientific world. Scientific developments of the nuclear age have long been at work in the components laboratories. For this oil filter test, radioactive impurity particles are placed in the oil and pass through an oil filter rigged on a test rack. Radioactivity in the reservoir gradually decreases and is measured at scheduled intervals. The reliability of the filter is recorded with extreme accuracy by a gamma ray counter. Sonic experiments of a more sophisticated nature are being conducted by the research experts of the Physical Science Laboratory. The sounds of individual vehicles are recorded on a 7-track tape. The tape sounds are fed into this unique analyzer containing the pickup heads. A visual record of each individual sound made by the vehicle is plotted as a graph. Studies of graph patterns determine the precise sound characteristics of each vehicle. This type of data, someday in the future, may help to identify friendly or hostile vehicles from their sounds alone. Research is being carried out at the same laboratory in the thin film deposition of metals and dielectric materials on optical surfaces. Here, a vision plot from a tank's command cupola will have a thin film of an experimental substance deposited on its surface. After the apparatus is sealed and the air is pumped out, a pellet of the dielectric material is then heated to its melting point. It vaporizes and condenses on the surface of the viewing block to form a uniform thin film on the glass. These optical surfaces will reduce reflection and glare, or they can carry a current and work as de-icers. The men and women of the components laboratories of the Army Tank Automotive Center are playing a key role in keeping the modern Army on the move throughout the world. They combine the results of their research and testing to bring today's weapons to their highest peak of efficiency. It is their responsibility to meet the needs of today's defense at every point on the globe to which the armies of the free world may be called. And in a continuing program of development, the need to meet tomorrow's defenses are studied. In this way, drawn from a wide range of technical know-how, ideas and concepts for new vehicles and new weapons are started on their way into production and into the hands of frontline defenses. Here in Detroit, the men and women of Army Research and Development and commercial automotive experts work in close harmony. Research breakthroughs at these major automotive facilities are shared with the components laboratories. This cooperation between scientists and engineers of the Army and those of the private automotive industry is a must. Each must work to meet the demands for greater mobility and transportation in a fast-changing world. From engineering schools throughout the country will come trained minds to attack new problems. In the automotive capital, there is a vast reservoir of technical disciplines and training. The industrial heritage of this area has provided our universities with both teachers and students who will help to give us the best equipped, most mobile and powerful military machine in the world. Tomorrow's battles may well be decided by students in college today. ATAC's senior team of scientists, engineers, and technicians are regularly briefed and kept up to date on the current and future needs for mobility. Together with the immense production potential of our industrial centers, the readiness of our fighting forces on guard around the globe becomes an impregnable bulwark for the defense of the free world. And civilian personnel are facing space-age problems of producing sophisticated machines of war. Sometimes the work of these dedicated men and women touches the area generally reserved for science fiction. A giant X-ray shows imperfections in cast steel. A sensitive sound recorder reveals valuable information of mechanical performance. Test and evaluate until each piece of equipment meets all specifications for ruggedness and dependability. Research for vehicles of every type and description. Vehicles to fight in mountains, jungles, and on beachheads. Products of the world's greatest arsenal. Development of weapons ready to carry America's power to any part of the globe. Here is the story of scientists, engineers, and technicians who are advancing the frontiers of automotive science and technology. In the heart of Detroit, the world's automotive capital, is ATAC, the Army Tank Automotive Center, and its Components Research and Development Laboratory. These are the top-flight scientists and engineers from the laboratories. It is their responsibility to ensure the mobility of the Army of today and increase the mobility of the Army of tomorrow. The various materials that make up the components of the vehicles. Small growths, seen through the microscope here, feed on these materials. They grow at a fantastic rate, particularly in tropical environments. This could spell disaster in combat. The growth of these small organisms could immobilize a tank and cost the lives of many men. The search for effective ways of fighting these microscopic enemies is part of the challenge. Another enemy of vehicle components is ozone deterioration. Ozone molecules are always present. Okay, move out. Ever see a television camera flying? Or watch a moving wheel that wasn't completely round? How many times have you seen a swimming tank? 40 tons of it. In case you haven't already guessed, it's all in the interest of science. Part of the Army Tank Automotive Center at Warren, Michigan. At this huge installation, military... Theirs is a big job. They are responsible for the reliability of every component that goes to make up these modern machines of war. Upon their shoulders falls the responsibility to find and develop the components that will make our Army vehicles the best in the world. They must create new concepts. New materials must be found. New problems must be solved. The solutions to these many problems involve research into a great variety of fields of study. In the materials laboratory, important research is being carried on in the field of microbiology. It is the job of the microbiologist to determine if components built for use in Army vehicles are subject to biological attack. To achieve this, microscopic strains of fungi are grown on the